Good evening, sir.
Ankit sir, are you able to hear sir?
Yes, yes, yes.
Yeah.
Am I audible? Yeah.
Yes sir. Good
Yeah,
evening sir.
Okay, thank
Thank
you.
you for joining. I would like to introduce Dr. Ankit Dubey sir to the audience. It gives me a great pleasure to introduce our esteemed resource person, Dr. Ankit Dubey sir, who is currently serving as an associate professor in the Department of Electrical Engineering at the Indian Institute of Technology, Jammu. He also holds the position of associate dean of E&M under the Institute Planning and Management at IIT Jammu. Sir has received his PhD in electrical engineering from IIT Delhi in 2014 and completed his bachelor's in electronics and telecommunication from Chhattisgarh Swami Vivekananda Technical University in the year 2009. Sir received his doctoral studies. He had uh, received his doctoral studies in the year 2012 from University of British Columbia, Canada. He also published many papers related to his domain, and presently sir expertise list in diverse combining multi-hop transmission, physical layer security, power line communication, IoT, wireless communication. He has applied research extends to smart grid communication system, automation, and UAE detection using radar technology. He has successfully led multiple sponsor projects funded by government agencies and external organizations in the areas as visible light and power line communication, integration, smart grid development, and unmanned aerial systems. Sir also published numerous papers in reputed international journals and conferences, continues to make valuable contribution in the field of communication engineering. Beyond academia, he actively mentors technology startups related to data silos in the field of IoT, premix, and in the domain of artificial intelligence, helping the bridge gap between the research and real world innovation. With his vast academic experience, strong research background, and leadership in the technical innovation, Dr. Dubey sir truly embodies the spirit of academic excellence and applied research. Let us all warmly welcome Dr. Ankit Dubey sir to start the first session. Welcome, sir.
Thank you so much.
so you can share the PPT, sir, now.
Yeah, so just give me a second.
I will stop. Yeah.
So, I can try system. Okay, just a minute. Okay, so could you please allow me to share on the other
One minute.
that I have
I will make it
just
post.
joined?
Yeah, I will make it post. Yeah, now you can do it.
So I think I'm not getting an option here to join.
Share. You are the host now, sir. You are the host now.
Okay. So basically, we make
That share button.
yes, just a second. Yeah, so I believe my screen is now visible. So
Yes, sir.
using this slides,
Yeah.
yes. Check. So
Yes, sir.
good evening, everybody. So welcome to this session on Introduction to Vehicle to Everything or Vehicle to All Communication and 5G ecosystem. So I'll just tell you briefly about IIT Jammu. So we started in 2016 and we started at city campus, and now we have moved to our actual campus, which is on the way from Jammu to Srinagar, some 20 kilometers from the city, Jammu city, on the National Highway 44. So we have 450 acres of land for our campus, and recently we have built our second phase of the campus. These are some of the main highlights about IIT Jammu. So we started in 2016. The location is Jammu, particularly in Jammu city, and we have students and we have more than 180 students. So the data has been updated. So this was our previous campus. So this was called the transit campus of IIT Jammu. And now you can see from the transit campus, now we have built our phase one of the campus. And yeah, sorry. So we have now operating from our phase one, and phase two is under construction. So we have shifted to this side of the building. Okay, so this side. Okay. So just to brief about myself, so I obtained my bachelor's in engineering in 2009, and I got placed in NR switches through campus placement, and then I also cracked GATE in 2009 with All India rank of 119, and I also got opportunity to work with DRDO and ISRO as a entry-level scientist. But I decided to go for masters at IIT Delhi, and then I converted my MTech into PhD. So, and I was a visiting research scholar at the University of British Columbia, Vancouver, Canada in 2012 and 13. And in 2014, I completed my my PhD. And then I started working as a research fellow at IIT Delhi, and where I set up a lab on smart grid. And then in December 2014 onwards, I started working as an assistant professor at an IIT Goa. And then from 2019, I'm working with IIT Jammu. And recently, I was a visiting researcher at Queen Mary University and Ulster University, Belfast, UK. And last year, I got promoted as associate professor in the Department of Electrical Engineering at IIT Jammu. So we have a lab at IIT Jammu. We call this as a wave lab. So wherein we actually build the wireless technologies, and we do testing and validation of this
1 minute, sir.
setup.
I request
So we have
participants to
experimental
please
setup.
mute.
Ankit, sir.
Audible, sir?
Yes, yes.
Sir, you can unmute all, sir.
Sir, you click on unmute all, sir.
Participants, go to
So this must
ఆడు బాగానే ఉంటాడండి అన్నయ్య ఇంటికి వచ్చినప్పుడు ఇదన్నీ ప్రతిదీ కొంచెం ప్రశాంతంగా ఉంచాలి ఆ మొక్కలు అది
so from where I'll have to
that host control is there, no, sir? Host control.
okay, more.
1 minute, sir. 1 minute.
Yes.
Srinivas Raju, sir, please mute your phone, sir.
1 minute, sir.
Srinivas Raju, sir.
సరదాగా ఆడతాడు ఏదో అంటాడు మీ ఎటగారం ఆడరా నా మాదిరి నన్ను పిలుస్తాడు చేస్తారు కదా లేదా అదుకొని ఇదిగోను అంటాడు పెద్దోళ్ళు బుద్ధిలో పిలుస్తారు పెరిగిన మేడం పోస్ట్ మ్యూట్ చేయొచ్చు అందరినీ
Ankit, sir, are you able to?
I'm just trying, like, from where mute.
Yeah, you will find a.
So 1 minute, 1 minute. And now you can do it, sir. Now you proceed, sir.
Okay. Okay.
11%.
Yes. Yes. Okay. So basically, I wanted to just a second. Yeah. So there is a road safety challenge in India. So basically, India recorded more than 168,491 road deaths in 2022, and India accounts for 11% of global road fatality with only 1% of the global vehicle. So we have just 1% of the global vehicle, but our contribution towards road fatality is 11%. And the major uh, problem is the overspeeding, okay, that causes the crashes and that leads to fatal accidents. And next is the poor visibility, mixed traffic. So we have varieties of vehicles running on the road, and unpredictable pedestrian movement increases this risk further. So driver reaction time usually is 1.5 seconds, which is inefficient, or you can say insufficient for many sudden hazards. So suddenly there is a vehicle coming from on the highway from the village side and all. So there are lots of cross sections like that. There are lots of intersection where signals are not working, or if signals are there, people are not following the traffic rule. Okay, and that this 1.5 second is really insufficient for many such sudden hazards. And traditional sensor works only in the line of sight and degrade in fog, rain, and dust kind of environment. So many fatal hazards are not visible in time, so that require proactive communication. So that is actually the challenge that we foresee. So these are the data, or you can say these are the citation from where I got all these numbers. And if you see the analysis by Drishti IAS Academy, so they have listed, or you can say they have published that in 2021, how many road deaths have occurred, and it is what was the cause behind that. So you can see here again the speeding, 55.9% of the death is because of the overspeeding. You can see dangerous, reckless driving or overtaking has contributed 27.5%. And the remaining, you can see here, okay, the rest other causes are 9.9%. So if you just add them, like poor weather condition, driving under influence of alcohol or drugs, mechanical defects in the motor vehicle. So you can see here, most of the vehicles are working fine, but major problem is speeding and dangerous overtaking or reckless driving. So these two has major impact on the road accidents in India. So if you see the limitation of sensor only autonomous driving, or let's say we talk about there is a vehicle which is equipped with sensor and it can navigate, okay, by observing its environment. So in that case, if you see, you will find the camera struggle in fog and rain, also in the glare condition when there is a light which is incidenting on the camera, or when the low light condition is there. So if you believe on the only the camera based autonomous driving or camera based assistance, then there are problems of fog, rain, glare, and low light. Whereas when you see the LiDAR based system, okay, so LiDAR is another way of imaging. So it performance drops in dust and heavy rain because the RF signal gets absorbed due to rain and has limited range at highway speeds. Okay, so basically the sampling rate over which you are collecting your information and the speed at which you are traveling. So the scene is changing at very fast pace or the fast speed. So you need more sampling rate. So LiDAR has a limited performance in such scenarios. So radar detects distance, but often it offers poor object classification. So camera-based system can detect the object. It can also identify the object. Whereas radar can detect the distance. Okay, so there are objects at this distance, but it is very poor while coming to the object classification, like whether it's a pedestrian, whether it's a vehicle, what type of vehicle it is. So it is very difficult for the radar to perform all this operation in the real time driving condition. So these are the limitations of sensor only autonomous. Okay, so sensor provides only line of sight perception, whereas it cannot detect hazard behind large vehicles, around curves, okay, or beyond intersections. So which are very challenging, which are very, you can say, very important factors when we are talking about this sensor-based autonomous driving. Coming to the multi-sensor fusion, okay, so if there is a multi-sensor fusion still fails when the environment blocks all physical sensing. For example, you have camera, you have lidar, but let's say the condition is low light and there is a heavy rain. So both lidar and camera will not be able to detect or identify the objects, and thus it fails even though you are doing the fusion from the data, okay, or fusions of the sensor data. So that leads to another challenge. So V2X is required to extend this perception of 9 non-line of sight scenarios. So we believe that if there is a V2X communication possible, that may solve this problem. Currently, so you just imagine you have an autonomous system wherein all the sensors are placed in your vehicle and it is capable of observing near around what is there, and you are actually trying to avoid the obstacle. You are trying not to collide with the vehicle which is there in front of you using sensor only. Okay, so there is no communication happening between one vehicle to another vehicle. So I'm talking about limitations of sensors only autonomous driving. And these are the major limitation. Although you have camera equipped in your car, although you have lidar equipped in your car, still there are chances, still there are scopes where it fails. It fails, and this might lead to fatal accidents. So that's why just having sensor, just having onboard computing, and you are aware of the environment will not be sufficient. It will not be sufficient towards the autonomous driving or safe driving. So we need V2X kind of system wherein vehicle will communicate to another vehicle or to infrastructure or to pedestrian or to any other object or to other network. So we'll talk about what exactly V2X is and how it helps in achieving autonomous driving or safety overall, okay, which is the major goal of this V2X system: safety and autonomous driving of vehicles. Other advantages that you can draw from V2X is you can manage the traffic, you can manage your city, you can plan the next phase of the city and all with the help of data which has been collected with this V2X system. But at the core, the basic functionality is it should avoid collision. It should reduce the, you can say it should increase the safety norms. It should reduce the overall interaction. It should reduce the chances of collision. Okay, so that is the major goal. Apart from that, you can keep on building. Okay, you can keep on adding extra layers, or you can say you can keep on extracting extra out of this V2X system. So going next to our why V2X cooperative awareness is important. So for that, you just imagine there are multiple vehicles which are driving on the road. Although there are drivers, some of the vehicles might be driving themselves. That means driverless driving systems are also in place. And the vehicles have different requirement. Okay, some of the vehicles need faster access. Some of the vehicles are having more number of passengers and all. Okay, and they have their own capabilities. Okay, so what exactly we are talking about? Why we need V2X? That means cooperation awareness. Why we need cooperation awareness? So the first point, which is very important, is to share your speed, position, heading, acceleration, and what is your intent in real time. Okay, so the first point that we are discussing is vehicle share speed, position, heading, that means in which direction I'm moving, and acceleration, whether I'm accelerating, and accelerating, if I'm accelerating, at what speed I'm accelerating. If I'm braking, like if I'm applying brake, then what is the what is the amount with which I'm applying the brake, and what is my intent, whether I want to take right turn, whether I want to take left turn. Because as a driver or as a vehicle, I know this is my path. I'm going to take left turn from this intersection. But others are not aware of what exactly is my intent, whether I'm going to take left turn, whether I'm going to take right turn and all. Okay. So what we can do is we can share this information. Okay. So if you, so this will provide awareness beyond line of sight. So this provides awareness beyond line of sight, behind trucks, around bends, and the blocked intersection, which is not possible in simple sensor based and the you can say where the human is driving. So it is very difficult to get all these details. Okay. So you have a system wherein you are sharing your information. That means what is my speed, what is my position, okay, what is in which direction I'm heading, and whether I'm accelerating, whether I'm applying the brake, and what is my intent, like how I'm driving, okay, whether I want to reach fast, whether I want to go right, left, and all. Okay, so these are called intent. So it provides awareness beyond line of sight. Even you can also monitor the vehicles which is behind you, whether they are accelerating, whether they are coming towards you, they are moving away, or any other information that you would like. So it reduces driver and system reaction time by offering early warnings. So you can develop a system wherein you can predict. Okay. So let's say you are going straight, there are few vehicles which are taking left turn and they are coming with certain speed. So whether they will be able to cross before you, or you will be able to cross first and they will cross behind, okay, after you. So all these things can be managed. So early warning system, it creates a kind of early warning. And also it enhances safety. Okay, it enhances safety even in low visibility environment like fog, rain, and light, because you are communicating, right? So I'm communicating my location, I'm communicating my speed. If I only communicate this two, that what is my lat long and what is my speed, that is also sufficient for lots of accident avoidance. And it also helps complement sensors by providing 360-degree cooperative perception. So if you have standalone system of sensors, you are getting the objects, or you're getting the surrounding. Okay, you are getting the what is there in your surrounding. But here, if there is a cooperative awareness among the vehicles, you have beyond line of sight information as well. Okay. And this enables safer decision making in mixed traffic. Okay. And very complex road conditions. I hope this motivation or this part is very clear to everybody. Okay. Why V2X, why cooperative awareness is very important. When we move to the next phase, it's an evolution of intelligent transportation system. We call it ITS. Okay, so stage one was ADS. So this was sensor based. So there was a camera, lidar, radar for lane keeping, braking, cruise control. Okay, it is limited to vehicle's own perception. Okay, that means a vehicle is equipped with ADS system. Okay, and it is connected. Yeah, it is connected, and it can only see its own environment, and then it can take a decision. Stage two is for connected vehicles, wherein vehicles begin exchanging data with infrastructure and cloud, not to vehicle, between vehicle and vehicle. I'm saying vehicle begin exchanging data with infrastructure. Okay, and which enables the traffic monitoring and basic alert. Like I can predict the congestion, I can predict the routing, or I can provide real-time routing to each vehicles as well in turn. Okay. Next is stage 3 is cooperative ITS. As I was talking about earlier, the vehicles will share their data to each other. So vehicles share real-time safety messages with each other. It supports cooperative awareness and hazard prediction. As I told you, if we know how vehicles are moving, what are their probable trajectory, then we can avoid the collision. Okay. And if you can avoid the collision, you can reduce the fatality, accidents, and everything. Next is stage 4, that is autonomous plus cooperative system. So we are talking about you have fusion of sensors, plus you have a kind of V2X communication where there is an edge and cloud computing is also coming into picture for the collecting data from all the vehicles and all the infrastructure, and then giving you live traffic updates, and also to give you beyond line of sight information. It enables higher autonomous automation and safer decision making. So you can run autonomous vehicles on road, and if there is a mixed traffic, if there is a traffic where there is a manual driver is there, human driving is also there, then all this can cooperate together, and this will give you a kind of environment where everything is communicating to each other for higher automation and safer decision making. So with this, I would like to just show you how the future ITS infrastructure will look like. So you have traffic lights, and there is a roadside unit. There is a cellular network, which is helping all these vehicles to communicate to each other. And also it is providing a link for roadside unit or this traffic light signals to actually take the real-time data and use that real-time data to manage the traffic, to avoid congestion, to provide real-time updates on traffic. Also, this will help the vehicles to get aware of the environment beyond line of sight. That means non-line of sight environment as well, and it will avoid serious collision. Okay, so that is the major goal of this ITS system is. Okay, so we'll talk about the key terminologies of intelligent transportation system. Okay, or which is also can be cellular based ITS. Okay, so ITS, which is intelligent transportation systems, it is a technology enabled system that improve road safety, traffic efficiency, and mobility using sensing, communication, and automation. So what we need is we need to sense and then communicate and then achieve automation. That means we have sensors which are helping me to collect the data within vehicle and outside vehicle as well. Okay. So when we talk about within vehicle, our data points, can anybody tell me like what kind of data I can generate? What kind of data I can collect using sensors within vehicle? Anybody? What kind of data we can extract from our vehicle? Yes, speed, acceleration, direction. Very good. Braking. Okay. So has any one of you or is there anybody who has worked on the vehicle to vehicle data or extracting out the data from the vehicle, from the four-wheeler, especially from the four-wheeler, two-wheeler, or from the electric vehicle? Okay, so if you have not worked on any of such projects, then let me tell you, it's very simple. Okay, you can just look at the vehicle. If you have a four-wheeler, what you do is you just see there is a OBD port. Okay, there is a OBD port, and let me just share from here as well, if I can. Yeah, I'll share that later on. Okay. during the interaction phase. Just remind me that I will tell you like how you can extract the data out of your own four-wheeler, okay, or your own vehicle as well. Okay, so when we are talking about this intelligent transportation system, I'm not collecting the data within the vehicle, but also outside vehicle. Outside vehicle means, let's say you have a vehicle and it is equipped with lidar, radar, or maybe camera based system. So you are actually identifying how many users are there nearby, or how many objects are there around your vehicle, what are their distances, okay, and whether they are moving or they're stationary. And you can send this information to nearby vehicle or to the cloud. Okay, so that is what exactly the intelligent transportation system does. Okay, it senses and then it communicates and then it achieves the automation. Okay, with the help of this data, you can achieve the automation. Next, coming to the cooperative ITS. Okay, so the extension of ITS where vehicle roadside unit, which is called RSU as well, roadside units, and cloud system share real-time information to enhance cooperative awareness. So it is extension of intelligent transportation system where you are just doing the sensing and communication to the nearby vehicle. But when you are talking about cooperative, you are sharing with other vehicles, you are sharing this information to the roadside unit, RSU, which is called roadside units. And these roadside units are also connected to cellular network or to the cloud, so that this data can go to the cloud where higher level decision can be taken. In this ITS, there is very important hardware which is required, or which actually helps to gather the data in vehicle system. Okay, so which is called OBU, okay, which is onboard unit. So this there is a port which is called OBD port, onboard vehicle digital port. So this OBD port helps you to extract the data, which I was talking about. So there is an onboard unit. So in vehicle module, which supports V2X communication like DSRC, cellular V2X, or new radio V2X. We'll talk about all this in detail in upcoming slides. Along with this onboard unit, so you have intelligent transportation system, okay, where they do cooperation. But for that, you need onboard unit, which is there inside your vehicle, which can extract data from the vehicle or whatever objects are there in the surrounding. It will gather all that, and then it will help this vehicle to communicate to different infrastructure or to everything you can consider. So this OBU is very important hardware. Next, coming to the RSU, as I was telling you, roadside unit. So these are infrastructure nodes which are placed along the road for vehicle to infrastructure or vehicle to network communication and edge analytics. And then comes the cloud or backend server, you can say. So these are centralized or edge computing systems, which is used for traffic management, okay, and then maps, okay, high definition maps and coordination. So basically what happens is, if you want to process this large amount of data on your OBU, the onboard unit, it is not possible because it's power hungry and you don't have enough computation power. So to extract the advantage of huge amount of computational power, you send your data to cloud and everything is processed in the cloud, and then you receive the response back to your vehicle within fraction of second, okay, with very limited latency. And that is actually helpful for vehicle to X communication. Okay, so we'll talk about this V2X, V2I, V2N, everything. Okay, but for a moment, just try to grab this, just try to understand what are the key terminology in ITS and cooperative ITS. When we talk about the spectrum allocation for V2X, okay, so what are the frequencies over which this OBU, that is onboard unit of your vehicle, communicates to other vehicle or to other. That means V2X. So what is the frequency that you use? What is the center frequency that they use? So globally, if you see, this frequency is 5.9 gigahertz. So that is the band allocated for intelligent transportation system and for V2X communication. In Europe, it is actual frequency starts from 5.875 gigahertz to 5.905 gigahertz. So 30 megahertz is allocated for ITS G5, okay, which is European Telecom Standard Institute, ETSI, European Telecom Standard Institute. In United States, FCC is the regulatory authority. So they have allocated 30 megahertz band, which starts from 5.895 to 5.925 gigahertz. Okay, this is primarily for cellular V2X. In China, the frequency allocated or the spectrum allocated for communication is 5.9 gigahertz for LTE V2X and new radio. That means for 4G and 5G enabled infrastructure, you can use this 5.9 gigahertz band to actually communicate between vehicle to vehicle or vehicle to any other infrastructure. In India, 5.9 gigahertz is under evaluation. So pilot trials ongoing with major OEMs and research bodies. And there are some level of pilot projects which are going on and the results are coming up. The kind of latency that we are getting, the kind of safety messages that we can exchange. So global trend is moving from this DSRC. I will talk about this DSRC, which was initially proposed for vehicle to X communication. That means vehicle to everything. Recently, every country or every organization has shifted towards cellular vehicle to X communication or new radio, okay, which are the two, you can say, upgrades wherein you are taking advantage of cellular network, okay, for vehicle to X communication, okay, rather than just having communication from one vehicle to another, direct communication. So they are providing, okay, you can introduce cellular based communication, just like our mobile communicates, just like our Internet of Things based solution communicates. So these are some of the references. Next, talking about the communication requirement for V2X. Okay, so what should be the requirement? What do you think? What is the major requirement for V2X? That means when one vehicle is communicating to other vehicle, one vehicle is communicating to other vehicle. What communication requirements do you think is very important? Anybody? Like, what do you Hello.
Yeah. Hello, sir.
So I was not audible earlier, or
No, now audible, sir. Now only audible.
oh, so
Previously also you're audible, sir.
mhm. Okay. So actually, I'm using two systems, so I'm not sure. This one is just a second. Okay, just checking. So now I'm audible, right?
Yes, sir.
Sir,
Audible, but your screen.
Screen
Now,
is
Yeah.
not.
yeah,
Okay,
now I
okay.
think my screen is visible, right?
Yeah, sir.
Oh, really? Okay. I don't know when it got muted. Okay. So we were talking about the communication requirement for V2X. Okay. So the low latency is very important. Like safety messages require 10 to 20 millisecond end-to-end latency, which is kind of real-time communication. Then you need high reliability. Okay. High reliability means the delivery rate, that means packet drop rate, or maybe you can say if the packet is delivered, whether those packets are successfully decoded or not. So we want all those things to be highly reliable, that is greater than 99.9%. Okay, so that is the requirement. Like when we say high reliability, high mobility support. So when your vehicle is moving at the speed of 250 km per hour or very high speed, even there are high speed trains, can we provide communication in such scenario? So my communication should also meet the high mobility support. Usually when we move, when we are communicating, we are moving at relatively lesser speed, up to 80 kilometer or 90 kilometer on highways. But you just imagine in future, your vehicle is operating autonomously. It is speeding with 200 kilometer per hour or more than that. Then how will you ensure that you are connected to the network and you are able to exchange information? Okay, so the communication requirements for V2X has low latency requirement, high reliability, high mobility support, then the broadcast nature. So most of the safety messages are periodically broadcast. It is sent every 10 hertz. 10 hertz means in a second, 10 times. Okay. In 1 second, you are sending 10 messages, which is the meaning of 10 hertz broadcasting. That means every second, 10 times I'm estimating my position. I'm estimating my velocity, braking condition, and all, and I'm broadcasting to all. Okay, so this is what the requirement is. Then there is a range requirement. Like effective communication range should be from 300 to 1,000 meters, so that everybody which are there, every vehicle which is there in the 1 kilometer range should be able to communicate to each other, sharing their information like the velocity, position, and other findings like obstacles. Even you can share the traffic update, live traffic update, and all. Next is the scalability. Okay. That means it must handle dense traffic. Sometimes there would be hundreds of vehicles broadcasting simultaneously. How your communication system will tackle this? That at an intersection, there are 50 vehicles which are sending their data of location and other details 10 times every second. Okay, 10 times. Then how this scalable solution would work? So that is the requirement for V2X communication. And then comes the latency, reliability, and range target. So as I told you, safety message frequency is kept as 10 hertz, which is for the standard. Okay. So basic safety messages can be exchanged, or cooperative messages should be exchanged every 1/10 second. Okay, every 1/10 second. Now the latency target is for collision warning. The communication should happen within 20 millisecond, and for platooning or control loop, you need 5 millisecond of latency. That means from one node to another node. Okay, what should be the time for data communication, for exchange of data communication? Okay, next is the reliability target. So safety critical messages should reach with 99.9% or better reliability. Urban dense scenarios require robust congestion control. And when we talk about the range targets, the range target typically safety range is from 300 to 500 meter, but extended range is up to 1 kilometer for highway and rural scenarios. Okay, so these are the latency, reliability, and range target. So it depends on factor like link budget, antenna gain, channel models, mobility condition, influence, okay, and achievable range. So next, coming to the IoT versus V2X characteristic. So this is very important to understand how V2X, like vehicle to everything communication and Internet of Things or Internet of everything, has a different perspective. Okay, how they are different. Comparing the mobility, in IoT, mostly it is static or low mobility devices. Whereas in V2X, it operates at very high speed that the device's relative speed could be 250 km per hour. Okay. Coming to the latency, the IoT can tolerate delays for 100 milliseconds to several seconds. Okay. Whereas V2X need latency in 10 to 20 milliseconds for safety messages exchange and less than 5 milliseconds for advanced use cases like for autonomous driving and all. So your exchange must be within 5 milliseconds. Next comes the reliability. So IoT, actually the best effort communication is acceptable, but in V2X, it requires ultra high reliable communication. Okay. In IoT, okay, you can wait for some time because not all the operations are mission critical, but here V2X is very critical because if you fail to deliver within time, with given reliability, probably you may collide with another vehicle and this might lead to a fatal accident. Okay. So that's why it's very important to meet all this requirement of mobility, latency, and reliability. The traffic nature, if you compare the IoT and V2X, the traffic nature in IoT is low rate, non-critical sensing data most of the time. Okay. So there are applications where IoT can be used in critical applications as well. But usually it is low rate. That means I'm monitoring the temperature of this room. So I don't need the data every 10 data every second. What I can do is every hour is also good. Every 30 minutes is also good for me. Then comes the V2X. Traffic nature is safety critical. High frequency broadcast, like every second, 10 times you'll have to send your location, or every 1 by 10 second, you'll have to update your location, your speed, and other findings that you have with your vehicle. Network topology, if we compare IoT, mostly is hub and spoke kind of model. There are gateways, and then there is a cloud. In V2X, we need direct communication between vehicle to vehicle plus vehicle to infrastructure plus vehicle to network. That means it should be able to communicate to roadside unit. It should be able to communicate to different vehicles. Also, it should be able to communicate to different networks. Okay, so there is a vehicular network and there are cellular networks. So it should be able to communicate with that as well. The environmental constraints. So V2X must perform with higher Doppler, urban multipath, and dense traffic environment. Okay. Whereas IoT, most of the nodes are fixed. So Doppler you can consider is negligible. Urban multipath might exist in IoT, but by better planning, you can avoid multipath propagation, or you can say you can just overcome this multipath propagation. And obviously, as we are talking about traffic, so IoT also sees a good dense traffic because upcoming trends in the industrial IoT or Internet of Everything is coming up. So we are talking about system where they're exchanging data very frequently. Okay. Although each node might generate very less amount of data, but there would be billions of devices which are communicating. Okay. And they are also standalone, or you can say there are cellular based communication and non-cellular based communication in IoT as well. So these are the major difference between IoT and V2X. Okay, that is vehicle to infrastructure. Next, we'll talk about the standardization bodies who are helping to make standards for this V2X. Okay. So definitely the IEEE, which is Institute of Electrical and Electronics Engineer. IEEE is the one of the largest technical body in the world. Okay. So this defines the protocol for communication. Okay. What frequencies we are going to select, what would be the details of physical layer, what would be the details of MAC layer, what would be the details of sharing between the users and all. So that is actually defined by standardization body. So IEEE defines IEEE 802.11p or ITS G5 for DSRC based vehicle to vehicle or vehicle to infrastructure. It focuses on physical and MAC layer for low latency vehicular communication. Next comes the 3GPP, third generation partnership. Okay. This 3GPP actually specifies LT V2X under the release 14 and 15. And for the 5G, that is the new radio V2X is under release 16 or 17. They define something called PC5. Okay. So PC5 side link and UU interface for cellular based V2X. Okay. So basically this IEEE defines DSRC for the direct communication between vehicle to vehicle, whereas 3GPP, that is third generation partnership project, they focus on defining the mode of communication between vehicle to vehicle and vehicle to infrastructure, how they'll communicate to the cellular base station. And then comes the one more body which is very active in this V2X standardization, which is Society of Automotive Engineers. Okay, they define message standards such as SAE J2735 for basic safety messages, your awareness messages among the vehicles. Okay, and SP80. So we'll talk about this messages in detail next. Next come the European Telecommunication Standards Institute, ETSI. So they define CAM, DNM, and full cooperative ITS protocol stack. So these are the key standards in Europe: EN 302637 series, EN 302665. So basically they also work. Okay, so different geographical region has different standards, okay, for communication, but most of them are interoperable as well. Okay, and then there are regional regulators as well, like FCC regulates in USA, in China, and just like in India, DOT or TRAI, they manage spectrum and deployment rules. Okay, that means, okay, under this standard, it says you can communicate, but whether it would be free, whether it would be paid, okay, or who will control, who will observe that they are transmitting under the safe range, or they are overspilling the spectrum and all. So these are the regional regulators. Okay, so when we talk about standardization, it's very important. Okay, I'll tell you why it is very important. This is standardization is we can take an example of tap. Okay, so when you go to any washroom, okay, if you rotate the tap in clockwise direction, it closes. If you rotate in anti-clockwise direction, it gets open. Okay, so if you buy the taps for your washroom or your kitchen sink, you don't bother about whether you are buying from which particular brand. All the brands, all the OEM supplies in the similar fashion. That means if you rotate it in the clockwise direction, it will get closed. If you rotate in anti-clockwise direction, it should get open. So this is how standard works. Okay, so let's say I am somebody who is actually manufacturing such taps, and I am using a reverse of that. That means when you rotate your tap in the clockwise direction, it gets open. When you rotate in the anti-clockwise direction, it should get closed. Now what will happen is you'll get fed up with such system, because in your house there are 7 or 8 taps in general, and you realize that the one tap has a very odd direction of opening and closing, and probably you will avoid such brand, or because it is not interoperable. It is not helping you to basically it is creating problem for you. So this is how standardization helps for the interoperability to design a system. Like when I am a designer of system, what should I keep in mind? That it should follow this standard. And if it is following this standard, then if there are devices of different OEMs, that means in the network, let's say your phone is of one manufacturer like Apple, Samsung, LG, or whatever. But your SIM card, so there are SIM card or the network provider, cellular network provider like Airtel, Jio, okay, Idea, and other. So what you can do is you can use them in, okay, and there is an interoperability between them. It does not mean that if you have bought this particular cell phone from this particular brand, you'll have to use this network. No, there is an interoperability, and it is only possible because they are following certain standard. So if you are buying equipment from different vendors, if they follow certain standard, then there is an interoperability, assurance that there would be an interoperability, and this will help in scaling, or maybe it is helpful for fair market as well. Okay, so that's why standardization bodies work to continuously update based on the technology which are upcoming or which are proven, to incorporate that into the standard, and everybody should be able to follow the standard so that they can create devices or equipment which are interoperable. Okay, so that you are not relying only on one set of tools. Okay, so if I summarize, so road safety challenge in India highlight the need for proactive safety system. Sensor only perception is limited by line of sight, weather, and you can say occlusion, because you are not able to see beyond certain point. V2X enables cooperative awareness, sharing real-time vehicle intent and status. And then ITS has evolved from sensor-based ADAS system to connected and cooperative systems. V2X requires, okay, so this 5.9 gigahertz spectrum globally designated for V2X deployment. V2X requires low latency, high reliability, and robust operation at high mobility. Clear distinction exists between IoT and V2X, and multiple standardization bodies have globally contributed for standardization. Okay, so moving to next, we'll talk about V2X fundamentals. Okay, so why V2X? Okay, so again, telling you, V2X refers to communication between a vehicle and any entity affecting or affected by the vehicles. Okay, it enables real-time exchange of safety, mobility, and situational awareness data, extends vehicle perception beyond onboard sensors. Okay, core components are V2V, V2I, V2N, and V2P. We'll talk about this V2V, V2I, V2N, and V2P in detail. It supports safety applications, traffic efficiency, and automated driving functions. Implemented using DSRC, cellular V2X using LTE or new radio, that is 4G or 5G, or hybrid approaches as well. Okay, so this is a all possible communication. Okay, moving to vehicle communication. So direct communication between nearby vehicles using short range wireless links like PC5 or ITS G5 DSRC. And it shares speed, heading position, acceleration, braking, and event warning. And it enables early alerts for sudden braking, forward collision risk, blind spot detection, okay, lane change intent, and all. It operates without network coverage. That means a device can communicate to another device. Similar way, a vehicle can communicate to another vehicle without having a cellular network. Okay, so direct communication is possible. Just like you use methods to share your data from one phone to another phone when those phones are nearby. So you open the Bluetooth and then you initiate the connection and then you exchange the data. In same way, vehicle to vehicle communication is possible. They don't need the cellular network always to communicate. they can communicate directly. Okay, device to device communication. It improves the safety in high speed and dense traffic environment. Broadcast nature ensures that all nearby devices or vehicles will receive the same information. Okay, this way they are all updated in real time and they can actually cooperate in some sense. Coming to vehicle to infrastructure, V2I. So the communication with roadside units, RSU, we call it roadside units, is called or termed as vehicle to infrastructure. RSUs provide signals, speed limits, okay, congestion, work zone alerts, etc. It supports MAP, SPAT, traffic optimization, okay, tolling, that means the charges for tolls and all. It enhances urban mobility, okay, it enhances urban mobility and intersection safety as well. Okay, so this next coming to the vehicle to network. Okay, so there is a V2N, so V2V, V2I, and then there is a vehicle to network. So vehicle connected to cellular network. So this is how we coin this term, V2N, vehicle to network, cellular networks, or maybe it could be any other internet networks as well. Okay, so supports cloud services and it helps for the traffic prediction, SD maps, fleet management. Okay, it enables large area alerts like accidents, weather. Sometime it happens in this northern area, there are road closure because of accident or due to natural calamity. So what are the alternate routes, which one to avoid, which one to take and all. So that is possible with the help of vehicle to network communication. It uses UU interface for G node B and E node B. So these are for 4G and 5G, the interface between vehicle to cellular network or to base station is termed as UU interface. Okay, so we'll talk about this as well when we'll talk about the 5G system. Okay, so next coming to vehicle to pedestrian. V2P is vehicle to pedestrian communication. So communication with pedestrian, cyclist, or two-wheelers. Like there are different types of vehicles now. So there are four-wheelers, how they will communicate to pedestrian, cyclist, and other two-wheelers. So that is actually vehicle to pedestrian. Smartphones, wearable, or RSU broadcast like location and intent. So I can also send an alert. Okay, so let's say there is a vehicle, okay, which is fire engine, which is moving along the city. It should be able to broadcast message, okay, to the nearby pedestrian that currently I'm on service and I'll have to immediately reach to certain location. So it will keep on alerting everybody before it reaches to intersection, before it reaches to a particular point, so that everybody will be alert. That means nobody is obstructing the path for that fire engine or fire brigade, or even similarly for the ambulance or any other convoy which is moving. Okay, so it prevents accidents in blind zone and urban areas. Sometimes it happens, you might have seen there are blind zone where you cannot see which vehicle is coming from the other side and you intend to cross thinking that no vehicle is coming, no horn is being played. So that may create an accidental scenario. Also, we have done several traffic analysis in the junction nearby IIT Jammu campus. So we have highway, which is actually connected to local areas, okay, which is coming out of the highway. So now there is an intersection of very high speed road and a low speed road. You can consider like that. So what happens is in such intersections, there is a huge chances of accident. Okay, so most of the vehicle are not colliding when they are going high speed or when everything is low speed. When this high speed and low speed roads meet, you'll find most of the accident happens in this area. Okay, so this vehicle to pedestrian can help to minimize that as well. Going to next is cooperative awareness concept. Okay, that is CAC. So vehicle continuously broadcast cooperative awareness messages and basic safety messages as well. It provides you 360-degree view of surrounding traffic. It enables prediction of future positions, that is trajectory, And if you can predict trajectory, it will change the road accident scenario in India completely. Okay. So if you develop an algorithm which has very precise way of predicting the future position, that means trajectory, it will definitely reduce the collision. Okay. And that will also help in reducing the decision latency for automated or autonomous driving systems as well. Okay. So these are very important factors under V2X. Next comes the basic safety message structure. What exactly is there in the basic safety message? Okay, that means every vehicle is bound to send. Okay, they'll have to, it is must for them to send the basic safety messages to nearby vehicle, or they must broadcast. So what it contains, it contains GPS location, that means position, speed, heading, acceleration, brake status, vehicle size. Okay. How frequently they broadcast is 10 hertz. That means every 1/10 second, they'll have to broadcast all this information. This is core message for V2V safety. Okay. So basic safety message. You'll have to send your location, your speed, heading, acceleration, brake status, and vehicle size or classification. Whether it's a car, whether it's a okay, so light motor vehicle, LMV, or medium size vehicle, or it is a heavy vehicle. So all those categories you'll have to update. Also, in future, there is a possibility that you can further categorize them, like whether it's an electric vehicle, whether it's a non-electric vehicle and all. So those information can be shared. But these are the must for basic safety message. Okay. Every vehicle will have to share this detail. Then comes this cooperative awareness message. CAM is for cooperative awareness message. Periodicity is 1 to 10 hertz. Describe vehicle state, that means position and dynamics. So just like a previous basic safety messages, here also the periodic frequency you can change from 1 to 10 hertz. Then there is something called decentralized, okay, decentralized environmental notification messages. It is event triggered. So the moment I detected there is an accident, there is an obstacle, or there is some adverse weather condition, it should be broadcasted. So this is decentralized environmental notification messages that will help the other vehicles to avoid that route or to get an alert a priori. Okay. So this is part of ETSI ITS G5 stack. Then comes the CPM or DMP, which is cooperative perception messages. CPM shares the detected objects from sensors. Okay. So again, now earlier we were talking about basic safety messages wherein I was sending the data from my vehicle, which was the actual condition of my vehicle. Now we are talking about cooperative perception message, CPM, wherein we are sending the data, whether I have detected objects, okay, using camera, lidar, or radar, that is being shared. Then there is a difficult to see objects or events. Okay. So those are also shared. It enables vehicle to see through occlusions and using each other's sensors. So it is very essential for advanced automation system. Sometime you might have faced this issue that there is a very heavy vehicle like truck or something is moving in front of you. You try to overtake that truck and then you realize suddenly another vehicle is coming from the opposite direction and you have a very close shave, or you were about to get meet an accident, and but somehow you avoided, or sometimes it leads to fatal accidents as well. Okay. So such systems, okay, such scenarios can be prevented with the help of this cooperative perception messages, wherein my device will share the information what is there in front of me, so that it will go to the device or the vehicle which is following me, so that it has a clear view, or it has a 360-degree view beyond line of sight as well. Okay. So that is what the advantage would be. We'll talk about the side link or PC5 interface for cellular network. So this is direct V2V or V2P or V2I communication protocol. Works without cellular coverage. this PC5 interface. Ultra low latency path, that means the message exchange happens at very fast speed. That means there is very low latency in this. It is used in LT V2X and new radio V2X. It is device to device. Okay, scheduling SPS, we call it sensing SPS. Okay, and you can see here vehicle A and vehicle B, so they can communicate to each other using PC5 direct. Otherwise, they can also share their information to the G node B. Then it goes to cloud, and then it can be sent back to vehicle A from vehicle B, or from vehicle B to vehicle A. Okay, so this is what we were talking about. Then comes the UU interface for the cellular link. So communication through the cellular base station. So your vehicle A communicates to cellular node like G node B, just like base station. Okay, it's a base station. So E node B or G node B from 4G and 5G terminologies. It supports V2N, that is vehicle to network services, cloud access, and wide area warning. If you are wondering like why why a vehicle needs to communicate to cloud, it could be for SD maps, it could be for real-time traffic updates, it could be for warnings and other system as well, or to optimize the path. When we are talking about autonomous vehicles, okay, or vehicle with assistance. It enables edge computing, that okay, so this helps to actually calculate or offload some of the tasks to edge, and then rest of the tasks will be computed by the cloud. And if you are using edge, then it would be faster. Okay, so UU interface can be used for vehicle to roadside unit or to E node B. Okay, so it has higher coverage but higher latency than PC5. So if you are directly communicating from one vehicle to another using PC5 interface, probably your latency is very less, very small. But when you are using UU interface for more data or for more information, probably your latency might be more. Coming to the message generation pipeline, like how messages are generated. So these are the 6 steps. So first, the sensor or the GPS receiver captures the data, then it fuses and validates, then message encoding, like which kind of message you are sending, like basic safety messaging or cooperative perception messaging. So depending on that, it will actually fuse the data from different sensors. It will encode them, securely signing, that means adding encryption. And then resource allocation will happen at the physical layer. That means which frequencies are available over which it will send, and then transmission will take place. Okay, it will ensure consistent and safe broadcast. Okay, so this is how the message generation takes place. Then comes the ITS security. Okay, so how this intelligent traffic system or will incorporate security is using public key infrastructure. Okay, or the certificates. So the public key infrastructure is used in V2X to ensure message authenticity, integrity, and trust. All V2X messages like CAM, BSM, DNM, CPM are digitally signed using short-term certificates. Okay, and then these certificates are periodically changed. Okay, so that nobody can hack into it, or nobody should be able to spoof. Okay, it prevents spoofing, that is fake vehicle positions, message tampering, replay attacks, etc. So short-term certificates or pseudonyms are rotated frequently to protect driver privacy as well. Okay, 2 major architectures which are there are security credential management system, which is US based. Okay, and ETSI, ITS, PKI Europe. Okay, components in public key infrastructure are root CA. You might have used this for your connection to any Wi-Fi network as well. So sometime you'll have to install the certificate, and then you enroll to CA certificate, then this get authorized, and then if you are doing misbehavior, so it can be detected. So it enables safe, trustworthy V2X message exchange, because here it is very important to actually encrypt the message. Okay, otherwise it may lead to some more challenges. And the data which is being gathered is from GNSS, okay, that is Global Navigation Satellite System. And you calculate your position, velocity, and time. It includes GPS and other satellite system. Okay, so India, we have IRNSS. Okay, so that is Indian Regional Navigation Satellite Systems. So we are now able to capture our location or to estimate our location from Indian satellites as well. Okay, if the global positioning system GPS satellites are not available, or if they were switched off in our country, still we'll be able to extract the messages, locations. Okay, so then there is something called IMU, that is inertia moment measurement unit. It measures the acceleration, rotation, your rate, etc., like how you are moving, and it maintains accurate motion estimate when GNSS is weak or you are going through a tunnel or cities. And then there is a CAN bus, that is control area network bus, for the in-vehicle network supply. How do you communicate with different sensors which are there inside your vehicle? So they follow CAN protocol, like wheel text, steering angle, brake status, vehicle speed. So they are internally communicated using CAN bus protocol. It goes to the central processing unit or the onboard unit, OBU. And then this OBU actually packs these messages. It gathers the acceleration and it gathers the GPS location, pack them into a message, and then it broadcasts. Okay, it broadcasts after encryption and all. So these sensors form the input layer for V2X message generation. Another very important factor is the time synchronization requirement. Okay, so this time synchronization requirement in V2X is very important. Okay, so there is a tight time synchronization. So this can be done with the help of satellite signals that we are receiving. It is required for accurate message timestamp in CAM and BSM, because if you are providing your location and if you are, let's say the message is received at a certain delay, but that location was at particular time instant, so that the other vehicle, when it is reading, it has a complete knowledge that this particular message of position and location was captured at this particular time. It is not like when it is getting delivered. So I estimated my location now at this particular time, like 7:44 p.m. And when I'm sending this message, it will take some time. When the other vehicle is reading that, it should not show the time of reception. It should show the time when the actual message, like position or acceleration, was generated. Okay, so I think you are getting it. Okay, so for NR, V2X requires even stricter timing due to slot-based scheduling in cellular network. In GNSS denied scenario, like if there is no satellite is available, vehicles rely on oscillator holdover. Okay, and network assisted time synchronization. So that is, again, you'll have to have an oscillator on board and you'll have to estimate the time. Okay, so this is very important, time synchronization. Next come the congestion control basic. So for decentralized congestion control is used in V2X. The key techniques are transmit rate control. That means you change your transmission range depending on the traffic. Okay, so you get a feedback whether your packets are transmitted successfully or not. You get an acknowledgement, NAC and ACK, and based on that you can control the rate. Okay, so if more packets are getting dropped, you reduce the rate. If you are observing that you're getting positive acknowledgement, you can increase the rate. Okay, so depending on the congestion. So this is one way to control. Another one is transmit power control, reduce transmission range to avoid unnecessary interference. Content control. Okay, so merge or suppress redundant events, same hazard reported repeatedly, so you can just avoid that. Channel monitoring, each vehicle monitors channel busy using busy ratio. That means it's called channel sounding. So you have a common channel and you are using the common channel. So you broadcast some signal and you listen, okay, before transmission. So this is called channel busy ratio. So this is being utilized for congestion control. Next is your geo networking overview. So geographical routing in ITS G5. So geo networking routes the messages based on the geographic areas, not IP addresses. Because with IP addresses, the problem is you don't know the geolocation of the user. Okay. So you broadcast this in entire network and you might get the messages delayed. Okay. So the main algorithm is greedy perimeters stateless routing, GPSR, okay, which helps you to actually route this through the network using geolocation. Okay. It is ideal for vehicular networks where traditional IP, oh, sorry. Just a second. Yeah, I believe my screen is visible, right? Yeah.
Yes, sir.
Yes, sir. The functions are like single hop broadcast to all nearby devices, okay, multi-hop forwarding, area-based routing, etc. So if we see in summary, what we have learned in this second module is we have defined V2X, explain its 4 modes like V2V, V2I, V2N, and V2P. We reviewed core safety messages like basic safety messages, cooperative awareness messages, etc. Okay. And we have seen why this is very important. Okay. So now we can move to the next part of the presentation is technologies for V2X. Okay. So it has both. You can see there is a direct communication possible and there is a network based communication is also possible. Okay. So 2 main families of V2X technologies are DSRC and V2X, that is cellular vehicle, cellular V2X. Okay. We define the physical layer, MAC layer, scheduling and performance. Global trend is shifting towards cellular from the dedicated communication, like direct communication. Now everybody is shifting toward cellular V2X. Both operates at 5.9 gigahertz ITS band. Okay. So this DSRC is dedicated short range communication, the same as our device to device communication. Okay. So, and because there is a shared channel, so you'll have to apply CSMS-CA because there is no central controller in this. Typical range that you can achieve is 300 to 500 meters. Good for broadcast messaging in low to medium density. And then there are challenges with this protocols as well. Okay. So the physical layer uses OFDM, 10 megahertz channel. Modulation is BPSK, QPSK, and it goes up to 64 QAM depending on the environment. The MAC layer is contention based, no scheduling. So you'll have to sense the channel and then transmit, and based on the feedback that you receive, you'll have to adjust your rate. Okay. It suffers with high channel load or the collision. Whereas in cellular V2X, okay, so it was introduced in 3GPP release 14, and it is also part of release 16 and 17. So there are 2 modes like PC5 side link, that is direct. You can communicate direct when it is required. Also, you can communicate using cellular network or the base station whenever you need to access the cloud. Okay, so it improves reliability and range over DSRC. It better handles the congestion via sensing based signaling. Okay. Coming to V2X physical layer performance, it is based on LT side link architecture. It also uses OFDM based physical layer with enhanced link budget. That means you transmit with more power, long range, you can achieve the long range. Then there is something called semi-persistent scheduling, SPS. So vehicle pre-reserves resources for periodic messages. That means I want to transmit at this particular time, I will reserve this slot and then I can use that for broadcasting. Okay, it helps maintaining reliability in broadcast heavy traffic. because you are reserving your slot and then you're transmitting that slot. Nobody else is allowed to transmit. Or maybe if somebody else is transmitting, then there is a cooperation between those devices and they can apply successive interference cancellation, which is called SIC, just like NOMA scheme. Okay. Then sensing based SPS also enhances for cellular vehicle to infrastructure communication. Vehicle sense channel occupancy before reserving resources. It avoids selecting already used slot, so reduces collisions. Okay. It is very critical for dense traffic scenarios. Yeah. So this is new radio V2X 5G overview. So in 5th generation mobile system, you can see here, it supports advanced safety, platooning, collision avoidance, cooperative perception, and sensor data sharing. It is more flexible and reliable than LT V2X. It has this LT UU, and here you can see this new radio UU interface. Okay. And it still uses LT PC5 for direct communication. So you can see here C2D, vehicle C2D can communicate using this LT PC5, or they can also communicate with NR PC5, new radio PC5, like 5G PC5. NR V2X design improvements, new side link modes, that means mode 1 and mode 2 can be selected for the communication. And there are 4 modes in total. So flexible numerology, like you can select the rate refresh. Okay, it supports a mixed periodic event triggered messages. Okay, and if you see the comparison between DSRC LT V2X and NR V2X, the range is in DSRC is 300 to 500 meter, whereas with LT you can achieve 1 kilometer. For new radio, you can increase the range of communication beyond a kilometer as well. MAC, CSMA. Give me a second. You can just see the comparison of this. You can see the comparison between MAC layer protocol as well. In DSRC, it is CSMA. In LT V2X, it is SPS. In new radio, it is advanced SPS. You can control the transmission rate. Latency is very low. In LT, it was lower, but in NR V2X, expected was high, but it is ultra low. Okay, that means because it provides you ultra low latency, ultra reliable, low latency kind of network as well. Okay. This is the comparison between long range vehicle to network and short range V2X direct communication. Okay, using LT V2X. It uses PC5 for direct communication and UU for the other communication. Okay. So latency requirement for basic safety messages 10 to 20 millisecond, already discussed. Advanced use case platooning, you need 5 millisecond or less. Reliability must be 99.99% for critical functions. And new radio V2X designed to meet this ultra reliable low latency type of net. Okay, KPIs. So you can see this is onboard unit. Okay, so OBU consists of GNSS receiver, security chip, antenna, which works at 5.9 gigahertz band, interface to vehicle CAN bus protocol. So inside vehicle, how it will achieve the data and how it will send this data to V2V, V2I, or V2N messaging protocol. So this is the role of OBU, onboard unit. And then after onboard unit, there comes the RSU, that is roadside unit. Okay, so this RSU enables V2I and V2N communication. One or more V2X radios like DSRC, it can have DSRC receiver, or cellular V2X or new radio V2X. Cellular, whenever I'm talking about 4G, and NR means I'm talking about the 5G and beyond as well. Okay. It also provides edge computing for local processing. It can act as, it has a backhaul network with fiber, 4G or 5G. The major function is your MAP and SPAT broadcast, traffic control, event-based dissemination as well. So this is the summary of our module 3. Okay. So I'll quickly try to go to next module, which is on communication stack. And just a second. So let me go to the module 5. Okay. So instead of 4, we can go to module 5. These are the examples. Okay, so let us see the yeah, I believe the screen is visible. Yes, now it is visible, right? Okay. So why 5G for V2X? 4G LTE V2X supports basic safety, but advanced functions are needed. So 5G provides us ultra low latency. That means less than 5 millisecond of trip delay. Then there is a high reliability, 99.999% is the reliability, high mobility support, high throughput for sensor sharing. So 5G enables cooperative perception, platooning, distributed sensing, high definition maps, update, etc. Okay. So backbone of connected and automated driving is your 5G. 5G system architecture for V2X. It has a G node B, which is 5G base station, 5G core, which actually holds the major part of the network. Then the multi-access edge computing system. Okay, so which is your edge computing nodes you can consider. Then PC5 side link. It supports both direct communication using PC5 and network communication using UU, which we have already seen. It is highly modular and service-based architecture as BA, which is what we called there. So PC5 versus UU interface, if you compare, PC5 is direct. So vehicle can communicate to another vehicle can communicate to pedestrian, vehicle can communicate to the infrastructure like roadside unit. Okay. And UU network is for vehicle to network, like cloud services. To access the cloud services, it goes through the UU network. 5G promises both for hybrid and reliability. Okay. So 5G new radio side link, this release 16 and 70, which features multi-traffic support. That is, you can send periodic or event-based as well. Flexible numbers, that means you can change your rate of communication from 15 to 60 kilohertz. Improved resource selection, high reliability under congestion, because it actually allow you to transmit and resolve the contention as well. Okay. So it is designed for advanced V2X like platooning and perception. Okay. So this is how it achieves the ultra reliable low latency network. Okay. Techniques, shorter range, shorter slots for mini slots or preemptive scheduling, redundant transmission. Okay. Second. Yeah, so we can now conclude the talk. So basically network slicing for V2X. So it allows you to safely slice the network in low latency, high reliable kind of system. And whenever we detect there is a V2X packet, I will forward this through low latency and high reliable network protocol. So I think we can stop here. Yeah. So
Audience,
we have covered the 5G use case. So I will share these slides where I have included 5G use cases as well. And so this was actually summary. So let me just summarize. 5G provides very foundational for advanced V2X, hybrid communication using PC5 and UU. And also NR V2X supports safety critical automation. And network slicing helps in delivering the packet with ultra reliable and low latency. It is suitable for cooperative perception, platooning, etc. Yeah. If there is any query, you can ask.
Audience, any queries? So mute yourself and ask any queries.
Thank you, sir. Thank you for a wonderful elaboration on V2X cooperative awareness, intelligence transportation system, and cooperative intelligent transport system, need of communication technologies, and different modes of V2X. Thank you. Thank you so much.
Arangini,
Yes, sir.
just wait for 1 minute. If any participant is
There, sir.
Sir.
Audience, any
Yes,
queries?
sir. We are requesting, sir. Participants, if you have any queries, please feel free to communicate with the speaker, sir.
You
Good
can
evening, sir. Sir, in your talk, you mentioned it as decentralized, right? So is there any chance for data hacking or spoof, sir?
Yes, there is a possibility of data breach as well. But what happens is all these messaging protocols use authentication mechanism, like you have a public key infrastructure. They use PKI, they get certificate, and then they use that certificate for encryption and decryption. So that way it is secure. But yes, if you are sending plain text, then obviously there is a problem. But usually they deploy a very low, you can say, certificate based public key infrastructure. So messages transmissions are secured.
Okay, sir. Actually, in IoT, we will be using like specific architecture like SDN, software-defined networking and all, right?
Yes.
So in V2X, do we have any specific architecture for implementation, or it will be varying according to the need?
Yeah, so basically recently people have opted for cellular based vehicle to X, that is vehicle to infrastructure communication. So this 5G new radio has complete protocol set for or the architecture for vehicle to X communication. So so what happens is generally the human to human communication requires more bandwidth, and there are some control channels which were available in the 5G new radio, and also they are utilizing the network slicing, that is virtualization of the network resources. So that helps in actually delivering the message fast and ensuring the ultra reliable low latency can be achieved. So yes, there is an architecture that you can follow for vehicle to X communication, both in cellular as well as in the non-cellular, that is that direct communication as well.
Okay, sir. Thank you, sir. Thank you very much.
Any other participants? Any query?
Any other participant want to have any clarification report regarding V2X? Any doubts? Please ask, sir.
Hello.
Yes, please.
Sir, how we can know if some data has been missed, or it can be like we are going to use encoding and decoding. If the data has been crashed, or if the wrong message has been sent, like when we are going to talk about intersected, you said that we are going to share messages. If the message has been passed false, or in the place of when we are going to change with encryption and to decryption, if the zeros has become 1 or the 1 has become 0, is there any like mechanism to get clarified that the message has been?
So there are two things. One is called the reliability in the data. So that is being ensured with the help of few physical layer parameters, like you can control the power, but you have a limited power to be transmitted. So you can ensure that, okay, you are transmitting with optimal power to meet the bit error rate requirement. So for this channel condition, this is the bit error rate that I can achieve. So what should be my transmit power? Second one is there is something called cyclic redundancy check, CRC, or there are encoding mechanism for transmission, okay, which is called channel encoding mechanism. So depending on the instantaneous values of the channel, you change your coding scheme and you can still achieve. So basically there are codes like LDPC codes, and there are other block codes which are available, which helps to actually transmit the message in the noisy environment, and you can detect the error. That means you can identify whether there is error in this received packet or not. And if there is any error, you can do correction as well up to certain extent. Okay, that is the role of this block codes. And there are varieties of block codes available. But for vehicle to vehicle communication, we prefer block codes which are lightweight. So
Okay.
this is regarding the reliability. Another one is regarding whether the message is authentic or not. So for that, we use public key infrastructure, wherein there are certificates which are being distributed. So they use their private key and public key to encode and encrypt and decrypt the messages. So that way it is secured.
Okay, thank you, sir. Thank you for your confirmation.
Okay, thank you, Dr. Tejaswini.
Any other questions, please, from participants? Would you like to share with sir?
Sir, is there any chance for using blockchain technology in this?
Yes, I have not studied much about the blockchain for V2X, but yes, there is a possibility because you have multiple devices which are broadcasting. So obviously you can authenticate and then you can identify if there is some spoofing going on. So because all transactions are visible to everybody in that particular geographical area. So yes, I think it is pretty much possible.
Okay, sir. Thank you.
Thank you. Thank you.
Yes, any more questions?
Yes. So there are emerging research areas in V2X is like physical layer security, using integrated sensing and communication for this V2X as well.
Any more questions from participants, please?
Tarangini,
Sir.
sir, thanks.
Okay, sir.
Anil sir on the line.
Okay, sir. Okay, sir. I thank Dr. Ankit Dubey, sir, on behalf of Department of ECA for providing us your valuable time and giving a valuable and informative session on V2X and 5G ecosystem and modes of V2X, V2V, V2I, V2N, and V2P. Thank you, sir. Thank you for your informative session. Thank you from Department of ECA.
Thank you. Thank you so much.
Thank you, sir.
Yeah, thank you, everybody. Thanks a lot.